All right, moving on. This next topic's going to be a little bit easier, a little bit more straightforward. We're just going to talk about flow control in Scala. So to get started, go ahead to the resources for this lecture and download the learningscala2.sc file, wherever you download stuff. And I will sit here and wait for you. So hit pause and take care of that, please. All right, let's move on. So we're going to right-click on Learning Scala, our Scala project here, and say Import, and go to the file system, browse to wherever you download your stuff. For me, that is, C Downloads. And select learningscala2.sc and hit Finish to import that into our Learning Scala project. And double click on that, and you should see this. So let's just talk about flow control. How do we control the flow of our code in Scala? It's all pretty intuitive. There are a few syntactical differences from other languages, but by and large, it should look very familiar to whatever language you're already familiar with. So, for example, you can use if-else syntax. If 1 is greater than 3, print line impossible. 1 isn't greater than 3, else print line the world makes sense. And sure enough, that will output the world makes sense. Now, I could also put brackets around this if I wanted to make it more than one line. That's okay. You'll see that down here, where I'm actually splitting it out to be a little bit more readable. Often in Spark code, you see people jam things onto one line just because they can, and that's kind of a common attribute of functional programming, I'm afraid. But either way works, so that's fine. There is no else-if operator, so you would have to actually do another, else after that if you wanted to. And that's all there is to that. If and else works just the way you would expect. Now, matching. So let's say you have like a switch statement in other languages where you have a value and you want to have different cases where you do something different depending on what value that variable has. So in Scala, that's called a match statement. So instead of switch, we use match. Other than that, pretty similar. So let's say we start with a constant value number that's set to the number 3. We can set number match would be the syntax here. So I want to match on the value of number, and for case 1, so you have this little equal sign greater than thing that sort of says, associate this function with that case. So that could actually be a whole expression if I wanted to, but in this example, we'll keep it simple. So in case 1, we're going to map that to printline 1. Case 2 will be mapped to printline 2. Case 3 will be mapped to printline 3. And then this underscore is basically your default, your catch-all case here. So case underscore, meaning it's something that's not 1, 2, or 3, will printline something else. But in this case, our number is 3, so it falls through to the case 3 and prints 3, which indeed works. So again, there's nothing really complicated going on there. It's just like a switch statement in other languages, but the syntax is a little bit different. We have match followed by the value name here, which is a little bit backwards from other languages, and we have this little mapping operator here, equal greater than, to actually map cases to what you want them to do. So that's the syntactical trickery there. For loops, nothing special about them. Well, a little bit syntactically. So look at what's going on here. We have for x 1 to 4. So basically we want to iterate through the values 1 through 4 inclusively. The only weird thing here is this little less than dash syntax here, and that is basically a range operator in Scala. So this says I'm going to take the value x within the range of 1 to 4, and it's going to create a list of 1, 2, 3, 4 and iterate through that in this for loop. So we will take here the square of each value. So for each value 1 through 4, I'll multiply it by itself and print the result. And we see 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and 4 times 4 is 16. So the for loop syntax itself is exactly what you would expect, but we have this new range operator here that's something new. So remember, that's how you specify a range of values in Scala. While loops, absolutely nothing interesting there. It works exactly the same as it would in other languages. So let's say I start with a x variable set to 10, and I want to iterate through this while x is greater than or equal to 0, while I subtract 1 for it as I go, printing the values. So there's really nothing fancy there at all. It does exactly what you would expect. We start with 10, and as we print the value and then decrement it, we'll keep on going until it hits 0. So 10, 9, 8 all the way down to 0. Just like in any other language. And just like we have while loops, we can also do while loops. Also, just like in any other language, there's really nothing Scala special here going on. We have basically starting with a value of 0, do print the value incremented by 1 and do that while x is less than or equal to 10. So instead of counting down from 10 to 0, we're going to count up from 0 to 10 using a do while loop. Again, if you have any prior programming experience at all, I'm sure you've seen this all before, and there's really nothing special about it when it comes to Scala. Works this way, you would think. Now, one thing I want to talk about, though, is expressions in Scala. And one thing that is a little bit different is that when you have a block of code like this, let's say I'm starting with the value of x equal to 10, and then I'm going to add 20 to that. Now, in other languages, that wouldn't actually do anything because we're not actually returning anything from that expression. But in Scala, this has an implicit value. So whatever the last expression is, will be what this expression as a whole is set to. So I can actually take this expression and use that as the value 30. So take a look at this. I can say print line, this expression, val x equals 10, x plus 20. That expression gets evaluated, and the number we're left with at the end is 30. So this all gets translated into the value 30, which actually is what gets printed out here, okay? So we're starting to touch on some aspects of functional programming here where expressions can actually be used as values of their own, okay? So that takes a little bit of wrapping your head around. So stare at those two lines a little bit longer and make sure that sinks in for you. Okay. Now just get your hands dirty. A little simple example here. You probably see this on a lot of sort of simple job interviews too. Print the Fibonacci sequence in whatever language you want. In this case, I want you to do it in the Scala programming language. Not hard. All you have to do is write a little loop that goes through the numbers 0 through 10, and the expected output should be something like this, where every time you go through the loop, you're adding in the sum of the two numbers before it. So basically you need to write a loop that keeps track of the previous two values, sums them up as you go. So little exercise in some flow control and doing some looping in Scala there for you. Have at it and have some fun with it. So I just want you to get your hands dirty. And again, just get some confidence that you can actually write Scala code that runs. All you have to do is write your code in here, and every time you hit Control S to save, it will get evaluated for you, and you'll see the result right alongside your code. So give that a try and see how it goes. On to the next lecture.